All right, so part 2 to 3.2 now is going to talk about the mean value theorem, which starts off similar. So it says if f is continuous on the closed interval AB and differentiable on the open interval, then there exists a number c such that the instantaneous rate of change is equal to the average rate of change. So instantaneous is just the derivative. Instantaneous. And average is this formula on the right-hand side. And they're equal to each other. Okay, but step number 1 is you have to make sure that you check if it's continuous or not. Don't give yourself more work. So the first example says, given f of x equals 5 minus 4 over x, find all values of c in the open interval 0 to 1, or 1 to 4, that satisfy the mean value theorem. Okay, so step 1, we're going to check for continuity. So if we look at the function f of x equals 5 minus 4 over x, I'm going to get a common denominator. Oops, x. So I get 5x minus 4 over x, okay? I have a vertical asymptote where x cannot equal 0 in this case, because then it would be undefined, okay? So that wouldn't work, but it's not in the interval. Not in interval. So given that it's not in the interval, f of x is continuous. So is continuous, so mean value theorem, abbreviated MVT, applies. So I can go further. Okay? So what this says, it says that we're going to take the instantaneous, which is the derivative. So if I'm taking 5, here's my function, 5 minus 4 over x. Let me just rewrite that once. So 5 minus, instead of being 4 over x, I'm going to make it 4x to the negative 1. Bring that denominator up so I don't have to use quotient rule. So the derivative of 5 is 0, and the derivative of negative 4x to the negative 1 is 4x to the negative 2. So that's 4 over x squared. So that's my instantaneous. Okay, part 2 to that is I have to get my average. So average says I'm going to do f of b minus f of a over b minus a. So I'm doing f of 4 minus f of 1 over 4 minus 1, and I'm subbing it into the original function. So f of 4 is 5 minus 4 over 4. F of 1 is 5 minus 4 over 1. So that's 4 for the first one, 1 for the second one. So I have 4 minus 1 over 4 minus 1, which is 3 over 3, which is 1. So I have my 2. So now what I'm going to do is I'm going to set my instantaneous equal to my average. So instantaneous is 4 over x squared. Average is 1. Make a proportion out of it, cross multiply, and x comes out to being plus or minus 2. Okay? But my interval goes from 1 to 4. So x equals 2, positive 2 that is the only answer that works. Okay, so continuity needs to be checked first. Then you figure out the instantaneous, then the average, set them equal, solve, and just double check on that interval. All right, let's try another one. So we see a square root function. So I know that my domain here, I'm going to take the value underneath the square root, set it greater than or equal to 0, because that's all that it could equal. And when I do that, I end up with, let's say, if I move the 2 over first, and then I divide by negative 1, I get x is less than or equal to 2. Okay? Well, if x is less than or equal to 2, that partly satisfies that. So we know this is continuous. So continuous MVT applies. All right, so step 1. Here's my function. First thing I'm going to do is kick out that square root and make it to the 1/2. So now I'm going to find the instantaneous. So I'm going to do my power rule and finish off with my chain rule. So I get negative 1 over 2 radical 2 minus x. And then I'm going to take my average, and I'm going to do f of 2 minus f of negative 7 over 2 minus negative 7. When I plug 2 in, I get 0. When I plug negative 7 in, I get 3 over 9. So negative 3 over 9 is negative 1/3. Then I'm going to set my instantaneous equal to my average. I have two fractions, which means I'm going to do cross multiplication. They're also both negative, so I'm just going to make them positive. So 3 equals 2 radical 2 minus x. Divide by 2. Square both sides. So 2 minus x equals 9 over 4. If I bring the 2 over, that's 8/4, so this gets me 1/4. So x comes out to being negative 1/4. And then you check on the interval -7 to 2, which does work out. So x equals negative 1/4 is a possible answer here. All right, one more of these guys. Not this one. All right, so given the function, find all values of c. So step 1, it's polynomial, so it's continuous. So mean value theorem applies. We're good to go there. All right, so we're going to get instantaneous first, which is the derivative. So 4x to the third minus 8. We are going to set that, or no, scratch that. Don't have to do anything there. Then we're going to get the average. So average would be f of 2 minus f of 0 over 2 minus 0. So f of 2 gets me 0. 0 gets me 0 over 2. So I end up with 0. So now I'm taking the instantaneous, set it equal to the average. I'm going to add the 8, divide by 4. And then I have to take the third root of both sides. So x is the third root of 2, and that is definitely a decimal, which falls within that range. So that's my answer for that one.